Hello, welcome to DIY Machines, where in this video I'll show you how you can 3D print and assemble your own Arduino powered domino laying machine. This video has been kindly sponsored by Skillshare. It's great fun to use and the easiest way to lay out some very big designs with ease. Its carousel is capable of carrying more than 130 dominoes at a time, and it's easy to swap so you can keep laying massive runs of dominoes before striking them down. To control the machine, you can either enter a pre-programmed list of driving instructions via the Arduino IDE, or use the Bluetooth on your phone to control it live, just like a remote control car. Its narrow design allows it to lay rows close together, and the provided code automatically takes care of spacing the dominoes appropriately, whilst also adding regular fire breaks should the dominoes accidentally start toppling. All that's left to do is fill in the gaps and knock them down. To build one of your own, you'll need a few components. I put links in the description below where you can find all of these parts on Amazon. You'll need an Arduino Uno, I'm using this one from Elegoo, 2 microservers, one that can turn 180 degrees and the other a continuous rotation one, one LM317 voltage converter, a battery holder for 6 AA batteries, a DC geared motor, I recommend one with a ratio of 1:90. A common motor driver board, 2 limit switches, a 1602 LCD display with incorporated keypad, an elastic band and the fluffy side of a Velcro strip. Of course you'll need some dominoes, lots of dominoes. Some hookup wire for connecting our electronics, a wiring block with at least 5 connections, a small selection of M3 and M5 bolts. Now you'll also need some filament for the 3D printed parts. I've printed all of my project in PLA filament, and the majority of the body I've used this silk silver PLA filament from G-Tech, which has given it quite a cool metallic look. The first part that you'll need to print for this project is called Main Body Closed Side. You'll find a link to all of the 3D printable models in the description below. I printed mine at a layer height of 0.3mm and used a 0.6mm nozzle to help reduce my print time. There is no need for supports on this part. Once printed, we can take the continuous rotation servo, cut off the connector, and then use plenty of glue to fix it into position inside this recess here. We can now take the first of our 2 contact switches and solder a length of 18cm long wire to both the common and normally open legs. On my switch, these are marked as NO and C. After threading its wires through this tunnel, carefully use some hot melt glue to fix this switch into position. Use a temporary glue like hot melt, as later on you might need to reposition your switch. You want the back edge of your switch to be pushed up against this small ledge. Take good care to keep the glue away from the switching mechanism itself. Add a couple of 10cm long wires to the DC motor. Make sure that the wires are exiting the back of the motor, and add some hot melt glue to act as a type of strain relief. Once our makeshift strain relief on the wires is cooled, you can glue the motor into position in the housing. Make sure that the shaft of the motor is aligned centrally in the hole by looking at it from the other side as the glue sets. Now we're going to continue adding some more 3D printed parts to our project. I'm not going to step you through every single part, but head over to my website and I've listed all the print settings I used for each of the parts to help you in deciding how you might want to print yours. Now let's add our 3D printed DC motor gear to the other side of our assembly. Use an M3x10 bolt to fix the cog in place. If you don't have a threaded shaft, then you can use some glue instead. The next 2 3D printed parts that you'll need are the drive axle and double cog. The double cog is held on the end of the square axle with an M3x10 screw. This can then be threaded through the opening in the side of our print so that it sits against our first cog. To complete this set of cogs, add a powered wheel with an M5 by 25 bolt. You'll need to tighten this all the way up, then back it up slightly so that it's loose and can turn freely. Next, we will attach the printable main body back part. This part is best printed on its back as shown, with some supports on the build plate. Once it has been completed and you have removed the supports, we can attach it to the rest of the machine with some M3 by 10 bolts. One through the access hole here, and one from below. Next, you're going to need to print the domino ejector and its arm. It's important to print this piece upside down. This helps to ensure that its layer lines are going front to back, which makes it easier for it to slide through our mechanism without catching on any other layer lines in our 3D printed parts. Attach the arm to the part using the M3 by 10 bolt. You can now slide the domino ejector into its housing. We'll then need to add the DC motor crank to the inside side of the DC motor. As we did on the other side, it is secured with an M3 by 10 bolt. Take the 3D printed domino collector arm and fix it through the long slot in its side to the post. Make sure that the jagged side of the arm is facing towards the back of the machine. Use the second M3 by 10 bolt to hold the ejector arm and domino retriever to the wheel by first laying the retriever arm above the hole, followed by the ejector arm, and then fitting the screw. Let's set this half of our project to one side for the time being and start to work on the other half. This 3D printable piece is called main body open side, and again I've printed mine in PLA filament, and you shouldn't need any supports. I've actually included both the STL and FreeMF files for these parts on my site. This enhanced file type includes a lot more information, such as the orientation of the part on the print bed, and whether or not I've used supports, infill, brims, etc. Let me know how you get on with the FreeMF files in the comments below, and if they're useful, I'll include them in future projects. For the majority of our ground connections, we'll be using a wire connector. I'm going to use this Wago one as suggested to me by my viewers in the previous video. It should be glued to the underside of the open half towards the back. Now is also a convenient time to open all of the arms up, ready for our wires later. Add a couple of wires to our remaining limit switch, one 23 cm long and the other 35 cm long. They need to be connected to the same common and normally open pins as we did on our first switch. This is then glued onto its little platform here. Once the glue has set, the 35 cm wire is threaded through just a few hoops before being threaded through this tunnel, which should exit at the top of the machine. Thread the 23 cm long wire through the hoops and around the pin before inserting it into the wire connector. It would be a good idea to start labelling these wires that pass through this tunnel, as there will be a fair few of them later, and it will make it much easier to tell which one should be connected to which pin. Use some masking tape to label it as A3, as this is the pin it will be connected to on the Arduino later. Whilst we're talking about pins and wires, I should mention I have also created a wiring diagram if you prefer to follow one of those. You'll be able to find a full resolution copy over on my website. Prepare 3 35 cm long wires and solder these to the pins marked as ENA, IN1 and IN2 on our motor driver. Now your DC motor board may already have some jumpers on it. You should check that there is a jumper covering these two pins. This will provide 5 volts to our Arduino and display from the batteries using the motor driver's onboard linear regulator. If there is another jumper blocking your access to the ENA1 pin, then you can remove this by just pulling it upwards with a pair of pliers. All 3 of these wires will then need to be threaded through the hoops and up through the tunnel towards the Arduino. Again, use some masking tape to label each of these leads. The wire coming from ENA should be labelled ENA, IN1 labelled as such and IN2 also. Connect a 22cm wire to both the VC and ground terminals, and a 30cm wire to the terminal marked as 5 volts. Thread the VC wire through the hoops and through this little window for connection to our battery later. The ground wire goes through the hoops all the way around to our collection of ground wires, and finally the 5V wire goes through the hoops and the tunnel to where the Arduino will be later. Add a label to this wire. At this point we can use some glue to fix our DC motor driver inside our housing. Inside the print towards the back you'll find a little ledge. The DC motor driver wants to be pushed up against this and glued to the base. You can now gently pull on the wires to pull through any excess. Let's set this half aside for a short while and turn our attention back to the first half that we were working on earlier. You're also going to need your 180° servo for this. Trim the connector off the end of the 180° servo and then peel the orange signal wires all the way back on both of the servos. Trim the length of the brown and red power leads to about 9cm. Pass the wires for the steering servo through the hole at the front of the main printed part which we assembled earlier. Keep the servo positioned in place with some glue. Aim to keep the servo level as the glue sets. Before we're able to use the LM317 to supply 6V to our servos, we'll need to set its output voltage using the onboard potentiometer. For this, add 6 AA batteries to your battery holder and connect it to the board's input terminals. Connect a multimeter to the output terminals on the other side of the board and then turn the potentiometer until you get as close to 6V as you can. Once done, you can disconnect both ends of the linear regulator's board. You can then wrap the matching pairs of power wires from our servos around each other and tin them with some solder before inserting them to achieve a better connection with our linear regulator. At the other end of our board, we can connect 2 new 21cm long wires to the 2 input terminals. We can then glue the module onto its ledge here. If you want to temporarily remove the screw holding the domino retrieving arm for easier access, that's just fine. Just remember to put it back again afterwards. These wires can then be kept tidy with the use of these hoops. Next, we can extend the orange signal wires coming from our 2 servos. Add a 40cm length of wire to each of the signal wires and then insulate the connection with some shrink wrap or insulation tape. Now is a great time to mark the wires before we thread them through the machine. This time I'm going to use a marker to put a black ring around the wire coming from the carousel servo, and I'll put 2 rings around the steering servo. Once both of the cables have been marked, you can thread them underneath the bridge at the end of the regulator's ledge. You can then pass these through the hoops in the other half of our main body and then up through the tunnel towards where our Arduino will be. We will trim these wires to a more appropriate length later on. Add a 17cm length of wire to the negative wire coming from the battery connector. Route this through the hole next to where the batteries will go later, through the hoops, and then connect it to our bunch of other negative wires. Whilst we're here, we can add a new 30cm length of wire to our bunch of negative wires and route this through the hoops and tunnel towards where our Arduino will be later. Give this wire a label which says ground. Take the ground and VC wires coming from our LM316 and connect this to the same terminals on the motor driver. So this bit is actually really hard for me to film. My hands are too big and they're getting in the way of filming it with the camera. So I'm just going to connect mine, you connect yours, and we'll carry on together again shortly. You will also need to connect the wires from the motor to the motor driver's terminals. The top wire goes to out 1 and the bottom wire on the motor goes to out 2. Okay, so I've just finished adding my wires as I described, and I'll show you a shot of what I've done. Start to bring the 2 halves of the assembly together while sliding any excess wire under the false floor beneath our DC motor. As you bring the 2 halves together, make sure that the square axle passes through this hole. You can then add 4 M3x10 screws through these access holes. And then additionally 1 here and here to firmly hold on the domino ejector assembly. To help keep our wires away from the mechanism inside our machine, you can pull on them gently from the Arduino end until they are more taut. Once done, we can add a second cog and wheel on the other side of our assembly. Next, we'll add our Arduino and LCD display to all our wires coming out the top of our project. But before we do that, I want to say a very grateful thank you to my patrons, all of whom helped to make these projects and videos possible. Thank you. These patrons are joined in this video by Rico, Patrick, Jeff, Emma, and Dustin, and Adam. If you'd like to consider supporting me and these project videos, then take a look at my Patreon page and YouTube membership page, which you'll find linked to in the description below. Thank you. So, if you take your LCD display and warm up your soldering iron, we can begin to add the wires. Starting at the top, from left to right, we want to first connect the signal wire coming from our steering servo, I marked mine with 2 rings earlier, to the 3rd hole along. This is then followed by the wire coming from ENA on the motor driver to the 4th hole, and then the signal wire from the carousel's continuous rotation servo should be marked with a single ring is connected to the next hole. Moving across to the bottom right run of holes, the leftmost hole should have the wire from the motor driver labelled as in1 attached, followed by either one of the wires from our carousel switch. The hole A3 should have the wire coming from the other limit switch connected to it. A4 is unused, and A5 is then connected to in2 pin from the DC motor driver. This leaves us with the wire marked as ground and the remaining wire from our carousel switch, which both need to be connected to the ground pins. These are unlabelled on this shield, but they are the 2 sat between the 5V and VIN pin. Last but not least, connect the 5V line from the motor driver to 5V on the Arduino. So just before we attach the LCD display on top of our Arduino Uno, there's one more wire we need to connect, which we should have done earlier. But no problem, it's just the positive lead from the batteries. Solder the 2 wires together and then add some insulation tape or heat shrink around our joint. Now that we actually have all of our wires soldered, we can attach the LCD display onto our Arduino Uno. This is simply done by aligning the pins to the headers and firmly but gently pushing the 2 together. So we will be adding a housing to our electronics later, but for the time being we'll plug it into our computer and upload the code so we can test everything we've made so far. This way, if we uncover any problems, it'll be quite easy to fix them. But if everything goes well, and it should, then we'll add the housing and get one step closer to laying our domino tracks. I have placed my machine on top of this blue box as it will try to drive forwards and backwards whilst we test the code. Connect your Arduino to your computer with a USB cable. Download and open the code, there is of course a link to it in the description. You can then set your board type to Arduino Uno and also ensure that you have the correct port selected before pressing upload. If all goes well, you should see your display light up, but don't panic if you can't immediately see any characters on it. You may just need to adjust the contrast using this small potentiometer in the corner. Use a screwdriver to turn it until the text becomes legible on the screen. It may take a lot of turns before you see anything happen. Just a quick word of warning, it's bad for the health of your Arduino to connect it to both a 5V power supply through its 5V pin and the USB port at the same time. So when you want to connect your batteries, disconnect the USB cable first and vice versa, and you should be just fine. Once you have connected the batteries, the screen should light up again as before with a message asking you to confirm that the carousel is removed from the machine. The carousel is this part, which we don't need to remove as we haven't got around to adding it into our build yet. So we can press the select button. This should cause the machine to find the position of the ejector block and the domino collecting arm by moving until it makes contact with this switch. Once that has been detected, the machine will stop and ask you to choose a control method. select IDE by pressing left. Later, once we've finished assembling our housing for the electronics, we will have some different 3D printed labels on top of our buttons. To help see the servos move, you can temporarily add a servo horn onto each of the 2 servos. Press select on the screen, and then the top servo should begin rotating in an anti-clockwise direction until you click the top limit switch, at which point it should stop and then rotate briefly in a clockwise direction. Now, if that has gone as intended, we'll move on to testing both the steering and the main domino mechanism itself. This time, we'll press the up arrow. The carousel servo will rotate again, so you should click the limit switch manually as we did before. You should then see the machine try and drive itself forwards for a short while. Then it will turn to the right, turn left, and finally try and drive itself backwards. If this is what yours has done, excellent, we can carry on with the rest of the assembly. If not though, go back and check your workings so far. Next, you'll need the 3D printed wheel support. You can then take the remaining M5x25 bolt and screw it all the way through of the underside. This is then fitted onto the main assembly and held firmly in place by tightening it down with 4 M3x10 bolts. We can also fit the 3D printed carousel cog onto our carousel servo. You should be able to secure this in place with one of the screws included with the servo hardware. For the steering assembly, you're going to need a few 3D printed parts, some screws, some bolts, and a rubber band. Use some super glue to attach the rubber band to the outside of the wheel. You'll need to treat both these wheels in the same manner. Use the 2 M5x15 bolts to attach our wheels to either side of the post. The side with the raised section should be facing towards the post. Don't forget you'll need to tighten the bolts and then back them up just enough to allow free rotation without them wobbling too much. Use 2 M3x6 bolts to fit the oval slotted ends of our steering arms to the steering post. The oval ends allow a little bit of play in the steering. The other end are circular holes which should be attached to the servo horn at the 2 outermost points. Use the sharp screws that came with the servo, screwing them down until about 2mm worth of the screw protrudes from the other side of the horn. Because we've been running our code on the Arduino, you should find that the steering servo at the front has been left in a neutral position, which is forward for our steering. So we can slide our steering assembly into its outer sleeve, and then fit the servo horn onto the servo, so that the 2 wheels at the front are facing dead ahead. We can now 3D print our carousel, which is going to hold our dominoes, about 140 of them at a time. Once printed, you'll find a part at the bottom I have designed to be snapped off. To make sure this works as intended though, you're going to need to make sure that your slicing software skips a layer in this central column, which creates a temporary custom support. The carousel can then be lowered onto our platform so that the bolt passes through the hole in the centre. The teeth on the internal gear mesh should also align with the small gear on our servo. Be careful not to snag the carousel on the contact switch. You should align it with one of the larger gaps found around the outside of its perimeter. To make reloading this carousel easier and quicker, I've created this small loading stick, which is slid up from the bottom of the carousel and makes reloading dominoes a little bit quicker and easier. As a way of supporting both this project and future projects, I've made this available as a download in exchange for a small donation to the channel. This also includes some fun 3D printable accessories. It's my way of saying thank you to you for supporting these projects. To help us in tidying up the electronics on top of our machine, there's a few more 3D printable things for you to print. The first one is the main body top, which is the enclosure that surrounds the electronics, and then there are a choice of 2 lids. One of them has a hole in it, so you can keep accessing the USB port whilst your model is complete, and then another one which has it hidden if that's what you prefer. You can also 3D print a set of buttons. To print these, I printed them in white and then changed the filament to black for the last 2 layers of the print. Once the parts are printed, I find it easiest to fit the buttons from inside and hold them temporarily in place with some blue tack. You can then slip all of this around our electronics, taking good care not to catch any of our wires. The 2 plastic rods on the end should end up entering the screw holes on the open side of our main body. We can use 4 M3x10 bolts to secure your lid and then remove our blue tack holding the buttons. The very last piece that you'll need is the battery platform, which is very simply just glued into place. And that's our machine complete. If you head on over to diymachines.co.uk, you'll find there I have written a detailed step-by-step guide that you can easily follow through, explaining how to program your own patterns into the Domino machine. Now you may or may not be wondering why I said you might need the fluffy side of a Velcro strip. Well, if you find that your dominoes are falling freely as they come out the back of the machine, you can cut a couple of 2.5cm lengths of the fluffy side and slide it up into this slot from underneath your machine. Use a dab of glue to bend it back around the corner and hold it into place. This will create some light resistance to help prevent the domino from toppling prematurely. If you find yours continue to fall, then you can add another couple of strips to the other side of the domino's exit path. Join me in the second part of this 2-part video series, where I'll show you how to add a Bluetooth module to this and then set up control using an app from your smartphone. It's my favourite way of controlling this. This video has been kindly sponsored by Skillshare. Skillshare offers thousands of inspiring classes for creative and curious people. They cover topics from design, video, photography, and much more. I'm currently enjoying a class called Creativity Unleashed. Discover, hone, and share your voice online by Nathaniel Drew. And I'm applying his points on sustainable consistency to my own YouTube channel. If you'd like to see that course, I've linked to it below. The entire platform is specifically curated for learning, so you're not going to find any adverts there, and their catalogue of premium content is ever growing, so you can stay focused and follow your creativity. All of this is available for less than $10 a month if you take an annual subscription. The first 1,000 of my subscribers who follow the link below will get a free trial of their premium membership, so you can start to explore your creativity. Thanks for watching. I hope that you've enjoyed the project. I know I have. If you know someone who may like to build one of their own, please share this video with them. You'll find links to Patreon, CAD files, code, etc. all down below in the description. So until next time, ciao for now. Let's set this half of our project to one side for the time being, and we'll start to work somewhere. You're also going to need some Emma and Dustin and Adam. Oh, I said Adam already.